Hello students. Welcome to your school YouTube channel. Today's topic is, why does a rainbow contain a pure spread of spectral colors? So without wasting time, let's quickly start the video and learn. A rainbow contains a pure spread of spectral colors because of the physical principles of light refraction, dispersion and reflection that occur within water droplets in the atmosphere. When sunlight enters a raindrop, the different wavelength colors of light are bent or refracted at slightly different angles. This separation of colors is known as dispersion, and it's the key reason why a rainbow displays such a vivid and orderly spread of colors. White light and its components. Sunlight appears white, but it's actually a combination of many different colors, each corresponding to a specific wavelength of light. These range from violet shortest wavelength to red longest wavelength. Under normal conditions, our eyes can't distinguish these colors separately because they blend together. But under specific conditions, like in the presence of rain and sunlight, at the right angle these colors are spread apart and made visible in the form of a rainbow. The role of water droplets. A rainbow is formed when light interacts with countless tiny water droplets suspended in the atmosphere after a rain shower. Here's what happens inside each droplet. 1. Refraction. As sunlight enters the droplet from the air, it slows down and bends. This bending depends on the wavelength. Violet bends more than red. 2. Internal reflection. After bending, the light travels through the droplet and reflects off the inside surface. This internal reflection causes the light to bounce back inside the droplet toward the exit side. 3. Refraction again. When the light exits the droplet, it bends again because of the dispersion that occurred on entry. The light now exits at slightly different angles for each color. Dispersion. The key to spectral colors. The phenomenon of dispersion is crucial. Different wavelengths travel at different speeds through water, so they bend by different amounts. Violet light bends more sharply than red light. As a result, the colors fan out into a spectrum, creating the banded appearance of a rainbow. This is why rainbows display colors in a very specific order. Red is on the top because it bends the least, and violet is on the bottom because it bends the most. The order follows the visible spectrum: red, orange, yellow, green, blue, indigo, and violet, often remembered by the acronym ROYGBIV. Purity of the spectrum. The spectrum in a rainbow is considered pure because it consists of continuous colors with smooth transitions, not mixtures or blends. Each tiny droplet disperses light in a slightly different direction, but collectively they reinforce a full arc of separated colors. Each observer sees a unique rainbow based on their specific angle relative to the sun and the raindrops. What makes these colors particularly vivid is that they are not mixed with reflected surfaces or other objects. They are seen against a background of the sky, which enhances their clarity. Conclusion. The pure spread of spectral colors in a rainbow is a beautiful demonstration of basic physics. The combination of refraction, internal reflection, and dispersion within water droplets separate white sunlight into its component colors. The result is a natural spectrum, pure and orderly, arcing across the sky. Each color in a rainbow represents light of a specific wavelength, made visible through the precision and predictability of how light behaves when it travels through water. This natural phenomenon reminds us of the intricate structure of light and the elegant simplicity of physical laws at work in our everyday world.